Hello, once again. So this is the last part of our lecture, basic statistics and application to nutrition. Yeah, I apologize for that. All right. Looking at the course content, is it the curriculum or syllabus? What do you even call that? Anyway, um, we have already treated measures of central tendency and dispersion, traces of graphic data presentation. I don't think I've done that, but I have done probability and level of significance. I've even sent the YouTube link of that lecture to your class rep, which will be distributed to you. And the formulation of a valid hypothesis and hypothesis testing, we've done that. Student teachers and one way analysis of variance. By and large, I think we've done that. The rest I gave you an assignment to go and read more about it. At this level, the ability to read and understand is part of the training. You know, that's how you learn how to solve problems yourself. You just need guidance. I'm here to guide you, not spoon feed you, right? So choices of graphic data presentation. This is not going to be a long lecture, it's just going to open your eyes to the potentials of the potentials of using basic softwares and sophisticated softwares to sell your data to a public, right? So, of course, you are familiar with bar charts. This is a bar plot, bar graph. You use them to present data. You can use different colors, but the resolution has to be good, right? Let me use slideshow. I think it will bring the beauty out of this presentation more. All right. This was one paper we published in 2021. These are some of the results. And then you see the statistical significance here, this C. These are called data labels, right? So we use them in statistics to show if there's a significant difference or not, right? This black chart here is total polyphenol. So between these samples, A here, the total polyphenol in NFP is higher than the rest. B is the second, C is the third, D is the fourth. So we used to show statistical difference, or we did in the last class. So if you're presenting a bar chart like this, you use data label, we are trying to make it easy for people to interpret your statistics. They already know you're using a P 95% confidence interval. Your level of significance is 0.05. So for this A to be greater than B, it means the P value is less than 0.05, right? Okay, so, and then this is another chart, the same comparison applies. So for this tartaric acid here, for example, if you notice, sample young tea leaf and mature tea leaf here, I have the same data level. It means the concentration of tartaric acid in these two samples are not significantly different. That's the interpretation here, right? So the same thing here for the tables. You can take your time and study this, just to show you some ways of presenting data instead of just charts and boring tables. You can also have, if you're dealing in chemistry, biochemistry, biological sciences, and you have to draw chemical structures, there are softwares where you draw your own chemical structure instead of just downloading images from the internet with very, very low resolution, right? Okay. So some people also present data labels as asterisks or stars like this, right? So this asterisk here, we are saying the as significant because they are comparable to the controls. The controls here are significant in decreasing the production of reactive oxygen species. So if you want to know more, about this, you can read my paper. You have the title in the previous slide. All right. Now, this is what we call a reader plots. People who do sensory evaluation, people who do nutrition, by and large, I see some data that require a reader plot. More people present them as tables. They look very confusing and boring to interpret, right? But if you use a reader plot like this, here we are telling people that maybe we made a juice or some kind of wine, right? So these are the groups. One wine has 0% tannin, the other one has 0.25% tannin. 0.5% tannin, these two are standard Longan wine. Longan wine, 6% and 12%, right? So the appearance here looks good, 7. It's for 0.5% tannin, right? And for 0.25% tannin, they look to be higher. And the Longan wine is not even as high as the samples treatments, right? So these are ways to interpret data instead of just using bar charts all the time and tables, right? The aroma, you compare these groups here, the further you go, the better, right? 1, 2, 3, 4. The further away from the center, the better, right? The sample. 1, 2, 3, 4, 5, 6, 7, right? So the highest score is better. So the sample with the highest score is better. The fruit flavor, sweetness, sourness, and all that. So basically, this is looking good, right? Okay, and statistics, people who want to use correlations and things like that. Well, if you're using regression, you do standard curves, for example, in biochemistry all the time. Positive regression, positive correlation, negative correlation, and things like that. You can read about that if you want. This is called a survival plot, Kaplan-Meier survival plot. They use it in a lot of time series research if you want to test survival of patients, maybe disease patients or even animals. Scatter plots, of course, they're there. Pie charts, you know what a pie chart is, right? You can use pie chart to show percentage difference between 2, 3 groups, something like that. Very creative ways of presenting data overall. Yeah, I've shown this already, but just to give you an understanding of what a correlation is. Strong positive and linear correlation. The higher, if y increases, x also increases. For negative correlation, as one is increasing, the other one is decreasing. And this is a non-linear, this is not a linear correlation. This is a weak positive correlation. Compared to this, you see the points are mostly around the line here, right? But this one, the sum of squares is going to be quite different from this one here. Look at your points. They are not as aligned to this axis as they should be. Weak negative correlation also. And here there's no correlation at all. Okay, and here you have what we call a chloroplex map. So we use Python or R to do this. I'm sure there are softwares that also do this, depending on the kind of data you have. Or just bear in mind, if you don't want to know more about this, you can watch other YouTube videos how they do it. If you're keen, as I am, in learning programming and data science, then you can try it, right? This is another chloroplex map. This is a heat map, hierarchical clustering. Yeah, it's very interesting. This is from a data I used actually. Okay, the Kaplan-Meier survival plots. I have mentioned this earlier. Okay, so thank you for listening. I've told you this is not going to be a very long lecture, right? If you have any questions, please leave it in the comment section. Don't forget to like and subscribe. You can share this lecture with your friends or family, people you think might benefit from this. Thank you. Share the YouTube link with them. Yeah.